Hi and welcome back to Physics 11. So one of you asked me to go over one of the homework questions from section 7.1, which deals with work. So question number 6 says, a 60-kilogram student runs at constant velocity up a flight of stairs. If the height of the stairs is 3.2 meters, what is the work done against gravity? So in this case, we're looking at work as a change in energy. In this case, it's going to be change in potential energy. Even though section 7.1 doesn't explicitly talk about potential energy, but we know that when you do work against gravity, you end up with essentially potential energy. So if you start, we're running up the stairs, so you start at the bottom, right? Let's make a stick figure here, right? And you're gonna go up the flight of stairs, which is 3.2 meters tall. So you're going up at constant speed, so acceleration is 0. So our change in potential energy in this case is going to be change in mgh. Now, delta means final minus initial. So our mass is going to remain constant, so mass doesn't change. Gravity doesn't change. It's going to be 9.8. So the only thing that changes is h. So when you write this, if you want to show every step, this would be actually your change in height. So if this is your initial point, that means that this is your 0 position, right? h0. And this at the top of 3.2 meters, this is going to be your h final. So we can call this our h naught and h final. So you can expand this and say, okay, this is going to be the same as our h finals minus h initial. And we get that equation. And if you actually plug in the numbers for the mass, we get 60.0 times 9.8. So that's 3 sig figs there. And this difference here, h final is 3.2, which is 2 sig figs. Our initial height is 0 here. So we end up with just 3.2, right? Because here 0 doesn't really do anything. So we still end up with just 60.0 times 9.8 times 3.2. And then once you multiply all of these together, 60 times 9.8 times 3.2, we get 1,881.6 joules. Now this has to be rounded to 2 sig figs, so we're going to round this up to 1,900 joules. All right, so that's question number 6.